Can everyone hear me? Yeah, hi. My name is Mohsin. So I'm going to switch gears a little bit and come from the system admin side to the application side. This part is authored by Mohsin Shaikh, my colleague. Because of the high turnover of people from Pawsey, in the interest of that, we decided I'll present it. So XDMod, we have been investigating a little bit about what it is and how we can use it. So a little bit about it. It's an open source tool, and it makes us aware of the HPC resource usage, and it can integrate. It can be integrated with different schedulers, the popular ones, Slurm, PBS, the grid engine, and then LSF. It can collect usage data from different clusters for different users on different projects. So here's an example from top left. The first element is total CPU hour usage, 10,000 feet view of the system. CPU hour breakdown by job size. Then we look at the average job size per core by core count, and then we look at the project status of usage and utilization on the system. Where would you use it? Well, identifying insufficient resource consumption by users. Let's say if someone is trying to run their job on 500 nodes, it's being run inefficiently. You identify it, you talk to the user, and then basically reduce the number of node count to run it efficiently. Identifying policy violations. Let's say somebody is running, we maintain debug queue for debugging purposes. The users might actually be running production jobs. If we see a pattern there, we can identify and talk to them through this tool. Creation of weighted service units, so not CPUs and GPU cores are not alike, so the accounting should be a bit different. So in order to make informed decision on the policy making, we can make use of this tool to actually come to a weighted service unit scheme. The next bit I'm going to talk about is application testing that we have been investigating. So the motivation here is, after the maintenance session, you would like to run sanity checks. You would like to see if all the environment available for the users is intact. In known applications, you would like to see correctness of the results. You would like to see performance and reproducibility of that performance and correctness. You would like to see if you have changed something on the system side, has it impacted overall usability of the application itself of interest, i.e. the regression testing. You would also want to use hopefully the same strategy to identify early detection of the problems. We have been listening to different approaches to this end since morning. So yeah, daily testing would be one of the use cases or motivation. So I was looking for a tool and found Reframe. This is a Python 3 based regression testing framework written by CSCS in Switzerland. They are using it in production. We are investigating what we should be doing with it right now. It is very configurable. It can run multiple tests on multiple architectures in multiple programming environments. It can run asynchronously. If you have a list of tests, long list of tests, but independent of each other, you can run them independently at the same time because you have a big cluster. Includes a large jobs workflow. Well, it itself, I mean, there is no point of it being scaling, but what you can do is you can accommodate the size or the scale of the jobs that you're going to run. It allows sanity and performance checking, and it supports Slurm and PBS. It is very well documented as well. So here's an example well, here's the scheme of how things are done in Reframe. You start with, the test starts with diagnosing whether it supports a system or not, it is a known system or not, it supports the environment or not, and then it moves on to setting up the test according to the test files requisites. Then if it is a compile, if it requires compilation, it will compile, run the test, run the check, sanity check, which is an optional thing. You can bypass that. You can also bypass checking for performance, but you can give a bound of plus minus threshold, and then it will pass or fail according to that. And then it will clean up the resources so that you do not have raw data sitting around for that, but you can keep the files if you want to, and then it will move on to the next test in the list. You can do that asynchronously as well, as I mentioned. So here's a snapshot of a run that I did yesterday, I guess. So I ran a set of tests which are composed under this -t regression right at the top. That's a tag which is actually bunching all the tests together, and it is going to run asynchronously. 2 of my tests failed. At the end, it spits out a little bit of information of the failed tests. One of the examples is this. I ran a luster test, and it was the write was underperforming, so this could be a flag. Last slide. So what Pawsey is trying to do with it is bringing up a pool of tests, basically, which does different scoping of things, basically. Regression testing, performance checks. So sometimes we are interested in performance of different subsystems. Systems checks, well, if the environment is intact or not. We can pull some tests, large-scale tests, which we do not usually run, but sometimes we need to stress the system in order to test some subsystems, for instance. So stress checks would be there. And then at the end, acceptance test would be something that would be run after every scheduled maintenance for the center. So future work involves adding continuous integration to do some automation of these tests so that we can diagnose things early, and would like to work on HTML dashboard so that you can have a report every morning, let's say, so that one can have a look at the systems at a glance from the application's perspective and confidently say that everything is okay or something needs looking at. Thanks.